Hello, everybody. Welcome. I guess that you all understand English, Charlie, excuse me, I'll start with the Hebrew, with the very... ברשות כל המכובדים, אני רוצה להתחיל בבדיחה שכולם מכירים, ואני מתחיל בעברית כדי לא להביך את האורח שלנו, תכף תבינו למה. אני זוכר שכשהייתי בממשלה, אז הייתה בדיחה שהרבה אנשים נהגו לומר, מה ההבדל בין שר להר, אוקיי? ומי שלא זוכר מה התשובה, הר, ככל שמתקרבים אליו, הוא יותר ויותר גבוה, אוקיי? אז הסיבה שאני אומר, יש אנשים שהם דווקא לא נראים כמו הר, ולא נראים גבוהים, אבל ככל שהם מתקרבים אליהם, הם מאוד מאוד גבוהים. וכאן אני אתחיל באנגלית. I'm very honored and very pleased to introduce to you our guest today, a person whom I met first about 7 years ago. When I was in the government, 6 or 7 years ago, when I was in the government, and being as Minister of Science and Technology, I was in charge of the Israeli Space Agency. And then we had a visit of an important delegation from NASA headed by the NASA administrator, Charles Bolden. I must say that quite rarely you meet such a big person with huge personality and with such a modesty. And Charlie is, before talking about his professional merits, he is one of the really most wonderful persons I've ever met. There's only in Hebrew, even actually it's not in Hebrew, in Yiddish, there's only the best word to really describe it is a mensch, okay? And he is a special mensch. A very, very sensitive person who doesn't see even, that sometimes his sensitivity brings him to tears and cry, and it's really not a weakness, it's his strength. Charlie Bolden started his career as a pilot in the US Navy, and later on became an astronaut who flew, I think, 4 times to space. 4 times more than I did. And he was appointed by President Obama to be the NASA administrator. I guess there's no need to introduce to you the NASA. NASA is, by all means, the giant in space. I don't know whether it's 80% or so of what's going on in space is related to NASA. But really, NASA is privileged to have a person like Charlie Bolden to be its administrator. And Bar-Ilan University, I personally feel very privileged to have a person like Charlie and his wife, Jackie, who is not here today. She will be here in the rest of the week. Anyhow, as friends. And I think that while Bar-Ilan University is going to bestow an honorary doctorate on Charlie Bolden tomorrow night, but I really think the honor is ours. So, ladies and gentlemen, please accept Charlie Bolden.
And Dr. President, friend, Rabbi Ruskovich, thanks so much for your very kind introduction and for the invitation to return to Bar-Ilan again, for some of you, particularly some of the students that I had an opportunity to meet when I was here in, I guess it was October, this most recent October, after being at a conference over in Jerusalem, had an opportunity to tour your beautiful campus and visit with some of your facilities. And as I explained to people then, I was kind of blown away about all that goes on here. And very encouraged by all that you do. We had a very brief conversation just before coming down here, because we're really excited about our ongoing relationship with the Israel Space Agency and with the nation of Israel. And we're really excited about the potential of things that we can do together, particularly on the International Space Station in the time that it has left in its lifetime, as we prepare to move on from where we today call the Earth-dependent region, or low Earth orbit, dominantly on the International Space Station, out into the next area that we call the proving ground, when we move away from low Earth orbit and back to a place that we know relatively well, which is the vicinity of the moon, and spend the decade of the 20s in lunar orbit and hopefully on the lunar surface with our international partners, our business partners, and entrepreneurs. And so it is my hope that some of you, if not all of you, will play a role in getting us there and play a part in that. Because it's in the 2030s that President Obama has challenged NASA to send humans to Mars. And that's not that far away. You know, we're talking about 14 years. So I don't know, any high schoolers here or lower, as a matter of fact? Anyone from high school? Back? I think I see some hands. Anybody here who's 15 or younger? Okay, for those, and you all turn around, look at this, raise your hands really, stand up. Those who are 15 years and younger, just stand up for a second. Okay, this is, thank you all very much. Now, are most of you with the Ramon Foundation, are you back there or down in here? Don't worry about it. But the young people that I just asked to stand, I call them the space generation. President Obama refers to them as the Mars generation, and I'll tell you why. Unlike many of us here, they have not spent 1 second of their life when human beings were not living and working in space. Now, think about that. Not 1 second of their lives have been spent when at least two people representing the United States and at least Russia have not been living and working on the International Space Station 250 miles above Earth, doing things to make life better for all of us back here on Earth. And I think that is something that most people don't know, don't recognize, because we have been accused of abandoning human spaceflight back in 2011 in the summer, when we finally phased out the shuttle and moved on to the next phase of human spaceflight. We were accused of abandoning human spaceflight, but nothing could be farther from the truth, because we've now been operating for almost 16 years with humans on the International Space Station. But all that said, it is an extreme pleasure for me to be back here at Bar-Ilan University again. Tomorrow, as the President mentioned, it will be my honor to receive an honorary degree from this great institution, and I am humbled just by the thought of that. I'm really looking forward to it. My wife is here in the country with me, and unfortunately, she is a typical wife. Not unfortunately, I mean, she's, that didn't come off right. It usually doesn't. But she loves Israel. We have friends who live in Tel Aviv, and so she's still down in Tel Aviv touring and shopping. Trying to take as much of Tel Aviv back home to Washington, D.C. as she can. You know, NASA has enjoyed a very long-standing cooperative relationship with the government of Israel, and I look forward to continuing dialogue between us in NASA and the Israel Space Agency to identify specific new cooperative initiatives under the framework agreement that we signed on the boundaries or on the outskirts of the International Astronautical Congress in Jerusalem last October. You all are incredibly innovative. The country of Israel is full of incredibly innovative people, and you always seem to be working at the cutting edge of technology, and we need you for our journey to Mars. We really need you for our journey to Mars. From our perspective at NASA, and let me stop for a minute. There are two rules that I usually have. I get in trouble when I give these rules because people know I have a whole bunch of prepared notes here. But when I tell you these two rules, I may get away from my notes and never get back to them. And that's okay, because what I want to do is try to answer as many questions for you today and help you know as much about NASA and our relationship with you, the people of Israel, and with this university and this Israel Space Agency as possible. And I don't have to read pieces of paper to do that. I do it usually better when you ask questions. So rule number one, you can ask questions anytime you want. There's a timekeeper who will stand up. Ruth, where is Ruth? Where's Ruth? Ruth is not here? Okay, I'm in trouble. But Ruth or someone will be the timekeeper, and when it's time, Ruth, no, you don't have to, I'm just saying, there is a timekeeper, that's usually the timekeeper, and Ruth will say, okay, shut up. You have asked and answered enough, so we will go as long as she lets me go. But that's the first rule. Ask questions when you have them. And the second rule is most important. There are no dumb questions. You can't possibly ask a question that somebody else in this audience doesn't have on their mind. You know, there are no dumb questions. Only the ones that remain in your head unasked. So please, ask questions anytime you want, and remember there are no dumb questions. But from our perspective at NASA, one of the most gratifying developments over the past few years has been the increasing number of nations who have joined the global exploration endeavor. You know, when I became the NASA administrator, when the president talked about us having met about 7 years ago, when I became the NASA administrator, people didn't talk about Mars, which was kind of strange, particularly for a space agency. But we just weren't talking about Mars at the time. I think people were afraid to talk about it. And I say afraid because, you know, everybody says, man, that's going to be really, really, really expensive, and it's going to be really, really, really dangerous, and it's going to be just take forever and ever and ever. Most of that's not true. It is going to cost, that's true. But in relative terms and in the return that we get on that investment, I think it's cheap. Risky, yes. Every time we leave this planet, it is risky. But trust me, everyone, and you all probably as well as any nation, know the price you pay when someone feels that it is worthwhile to explore. You should be proud that you have perhaps one of the ultimate explorers who is looking down on us right now from his perch, having had the opportunity to do what not very many people have an opportunity to do, to leave this planet and look back on us from the vantage point of space and see us in all our grandeur and beauty, and then troubling to wonder why we don't do better. You know, why we don't do better. Ilan is quoted as having said, you know, he remembers the first couple of days on his space shuttle mission, he looked back at the planet and he was trying to find his little village down here and making sure he could find Israel. And a couple of days later, he looked down, he was trying to recognize the region. And then several more days into the flight, he looked down and all he saw was his planet. And he realized that he was a member of the human race, a member of the species of human beings who occupy this planet. And the same thing went through his mind, I imagine, as has gone through the minds of almost all of us who have had an opportunity to leave the planet and look back. And it's to ask ourselves the question, why? You know, at NASA, we ask ourselves two questions all the time. How the heck did all this stuff get here in the first place? How did planets form? How do stars form? How did the universe get here? And then perhaps the most important question, and the one that I think we're oh so close to being on the verge of answering, is, are we alone? A lot of times people ask, why do you want to go to Mars? And we say, well, because it puts us one step closer to finding out whether we are alone, because Mars happens to be one of the planets that we believe harbors signs of life, if not life itself, in the form of microbial organisms or whatever, but that's life itself. And just imagine what it's going to be like, you know, for those of you who are of a religious bent when you know, the book of Genesis, how it starts out, and all of a sudden, after there was nothing, boom, there is everything. If we find life on another planet, then what does that say about the beginning of time? So that's why I think it's going to be incredible. You know, nations large and small, both with and without formal space agencies, have all come to the conclusion that everyone who has a passion for space can find a role and a place where their expertise is critical. In short, every single nation can play an important part in the ongoing journey to Mars, a scientific journey of discovery and the next phase of humanity's development as a spacefaring people. What was once a space race is now an era of global cooperation and collaboration, and our work in space helps us focus on the broader concerns of our world and making life better for everyone. We've always made the impossible possible, and I know the public pretty much has come to expect that. We're proud of our accomplishments, but behind the scenes, the magic just doesn't happen. It comes with a lot of planning, a lot of smart people collaborating and compromising, and above all, a shared vision of how we can raise the bar of human potential and improve life across the planet. And I'm shocked that no one has stopped me and said, what in the world is that? I think everybody recognizes Earth spinning around there. NASA built a satellite called Discover for the National Oceanic and Atmospheric Administration, NOAA, in the United States. And it is a weather satellite, sort of like, but there is a camera on board Discover called EPIC. And EPIC is a climatological camera, so it allows us to look at Earth and gather data that helps us understand long-term changes in weather, which is defined as climate. And one of the things I don't know that we thought about was what else we were going to see. Well, every once in a while you see the little ball go by. Well, that's not somebody playing with a ball, because it's 1 million miles from Earth, looking back at us. That's our moon. And it is time-lapse, but it's showing you know, how from the EPIC camera, the moon goes by now and then. And what is even more fantastic is you're looking at a side of the moon that you never see. Because I think most of you know, unlike Earth, the moon doesn't rotate. And so what you're seeing is what we refer to as the dark side of the moon. So I think that's absolutely incredible. If that sounds pretty big picture, well, it is. Our missions demand decades. You can leave it down, Ruth. You can leave them down. The lights. It'll be easier for folk to see the slides because there are more of them. And I think I can see hands when they go up, so we'll be all right. Our missions demand decades, even generational planning, in the case of our journey to Mars. But beyond technical, yes?
A few months ago, the Congress Science Committee wanted to ask you to stop researching Earth in exchange of more researching space.
Yes.
Yeah, you of course, didn't want it.
Yeah. No, well, what we were trying to help people understand, what we are always trying to help people understand is that a part of NASA's mission, a critical part of NASA's mission from our establishment in 1958 is to help preserve the planet, to help people understand more about the planet. And that's Earth science for us, so that's simply where it was. The quote here is actually from President Obama, and it came when he traveled to the Kennedy Space Center to deliver what I thought was a major space policy address that was missed by most people because they just weren't paying attention at the time. And in it, this is where he laid out the challenge to us to put humans in the Martian environment by the 2030s. And so we're really working to do that. Question over there. Yes, ma'am. I think I know what you're asking. Her question refers to the fact that, we now know, thanks to Hubble and other modern day telescopes and the like, that people used to wonder what was happening to the universe. Was it stable? Was it shrinking? Or what? And we now, I think most scientists agree that the universe is expanding. It is not like blowing up, however, okay? And so you have to think about how the time span in which we're talking about this expansion under which we're going. She's worried about whether or not, there's going to be no universe for us to be in when we go back and it boom again. No, I missed it. Yeah. Well, the interesting, I don't know the answer to your question, but eventually we're all going away. Eventually, but that is gazillions of years from now, because we live thanks to the fact that we're around a star. And that's what provides the heat and the energy for Earth and our sister planets to survive. But over time, like many other stars that we're able to study with soon the James Webb Space Telescope, but with Hubble, we understand how stars grow and grow and grow until they die out. They run out of energy, and they run out of fuel. And that eventually will happen to our star, but that is so many years away that I don't want any of you to worry about it, because there's a lot of stuff that we need to do to this universe in which we live to make it so much better, because there will be hundreds and thousands, if not millions of generations that come behind us. So your question is a very good one, but you and I don't have to worry about it. That's sort of a cop-out, but that's okay. Question over there.
So due to the recent discoveries you found on Mars, would you actually say there was life before on Mars, or?
I think we've always said that we believe that life existed on Mars. One of the things we know from planetary scientists and all their studies is that Mars at one time was we think was very much like Earth, very similar to Earth. Fertile, temperate, and a couple of things happened. One was, unlike Earth, it has this shell around it that we call the magnetosphere, this magnetic protective shell. Mars doesn't have one anymore, because there's a dynamo, that's a sort of a simple term, that died on Mars. Either some supreme being turned it off, or it just went away for some reason. So Mars doesn't have a protective shell, a magnetosphere, and so energy from the sun, particles from the sun, what we call solar weather, are literally scraping off Mars's atmosphere bit by bit. We now have a satellite called MAVEN that we put up 2 years ago, and it's actually studying Mars's upper atmosphere to determine how rapidly its atmosphere is evaporating or going away, so that we can figure out how much longer Mars will be able to sustain any kind of life at all. We're still talking, eons. We're not talking about years in our terms, anyway. But we do believe that Mars at one time supported life. The discovery, I think the one you're probably talking about is the ice flows, the liquid, essentially really cold water, but ice flows. What's magic about that? When you talk to what we call extremophilists, I made up that term, okay? Extremophilists, or scientists who study extreme beings, extreme forms of life, extremophiles. When people go down to the Antarctic and they go under the Arctic ice, they find life forms, they find microbes that have adapted to incredibly cold environments. These same people go inside a volcano, and they go right down above the lava where it is intensely hot, and they find extremophiles. They find microbes that exist at those temperatures. And so the rationale from scientists who have just actually made these discoveries of life forms say, wow, if that can happen right here on Earth, most certainly it could be happening on Mars. And so what was so different about the ice flows was now you've got water, really briny water, really salty water. That's what allows it to still be able to flow, is because it's so salty. But if we've got water, that is a source of life where it can support life. And so that's why they got really excited that if we could just get there, we're going to discover life. Now we've got the challenge of how do you because of international conventions, we can't get close to the water because you don't want to contaminate the planet, but we'll figure it out. Question over here, yes.
Wondering in your opinion, what's the most meaningful thing we can do as a human race?
Oh, what is the most meaningful thing we can do as a human race? Well, that's a philosophical question. But I mean, I think probably, and this is simplistic, learn to listen to each other. Quit talking and listen to each other first before we make a judgment, before we characterize somebody. That would be helpful. And the other thing is try to be open to disparate ideas and give consideration. We talk about diversity and inclusion at NASA. I am the diversity champion for the space agency. And I talk to my employee. We have 18,000 civil servants at NASA and about 40,000 contractors, and we talk about diversity and inclusion and its critical importance all the time. But I explain to them that diversity is okay, because diversity is what gives us, whatever the percentage of women is in the audience here, and whatever the percentage of Arabs in the audience, if there are, and others. That's not important, and it doesn't mean anything if we don't have inclusion. If we're not willing to listen to those who are in the forum and allow them to speak. An example I give, women will understand this one even here in Israel. In a business meeting, sitting in a boardroom, the chairman asks for a recommendation, and we go around the table, and the only woman on the board comes up with an idea, and it is brilliant. Nobody has thought about it. It is absolutely brilliant. And the chairman says, that's okay, and keeps going around. And about 3 or 4 people later, a young man or an old man gives exactly the same idea. And that is brilliant. I mean, I cannot believe we didn't think about that before. Now, for the men in here, you're probably saying, oh, he's kidding. For the women, am I kidding? Happens all the time. So it's inclusion, learning to include people. That's a very simplistic answer to your question, but it's not science. It's not anything. That is what makes for diplomacy, and I think that's critically important. We're doing a lot of technical things. I'll get right back to you. I'm gonna finish this page. Because I'm running. My mother taught me to put my finger down here, but my finger's starting to fade, so I'm going to go back and finish this page. I just talked about this journey to Mars on which we're embarked. There are a lot of technical milestones that we have to do, but the biggest thing we can do, going back to yours, is pass the baton to the next generation. That's what's critically important, and so that's what I try to do as I travel around the world, is help the younger generation, the Mars generation back there in the back, understand it. They're about to get the baton. And so if we're really going to get humans to Mars, they're going to be the ones to do it. It's not going to be anybody here on the front row, not me. I will be sitting in a rocking chair somewhere, watching hopefully one of my granddaughters be on the first crew to go to Mars, and I'm going to be just thrilled. Because at the end of the day, we can do all the outreach we want, but it's going to be the challenging landing on Mars, or the personal visit of an astronaut to a classroom, whether it's via TV or downlink television or in person, just to talk about their experiences on orbit. Those types of things that are going to inspire the next generation. Now your question, right there.
NASA has developed a product that came and improved the life of civilian life. Can you tell us something that you think we don't know about yet that might do it?
Oh, an example of something that you made?
Something we don't know about that you think can improve life that you're working on.
Oh, I don't have anything secret. If that's what you mean.
Something I don't know.
Yeah. No, you probably know about many of the things that we have helped to develop. An example I would give you would, most infants today, the highest rate of infant mortality comes from waterborne pathogens, from bugs in water around the world. And that's not just in third world countries, it's around the world. On the International Space Station, we are really, really, really concerned about our astronauts having fresh drinking water. And so we had to work on the technology to develop water purification systems. It can't be giant like here, you know, it can't be like a desalinization plant that's out here on the coast taking water out of the Mediterranean or taking water from somewhere else. It's got to be very small and compact, and so we developed that. That technology is now used in the US in some rural areas to purify water for drinking, to reduce the number of diseases that young people get now from waterborne pathogens. That's one example. Another one would be astronauts today on the International Space Station. I don't know how many of you have ever had an ultrasound. Ultrasound has become an incredible tool of medicine today, and you used to have to go to the doctor's office and you got on a table and this big machine. We don't do that on station. You can't have a big ultrasound machine on the International Space Station. The ultrasound device on station is about the size of this microphone, and the astronaut takes it in his or her hand and, you know, looks at their carotid artery. It goes, it beams down to Earth, and the flight surgeons in the control center can look at the ultrasound and help to diagnose a problem that the astronaut may believe they have, whether it's the intraocular pressure problem we're having that decreases vision or whatever. That technology is now used in places that don't have doctors handy, and that is frequently in third world countries where we can train a midwife to operate a handheld battery-operated ultrasound machine. It goes 200 or 300 miles away to a doctor. The doctor, looking at an expectant mother, can say, okay, she's okay or she's not, and do stuff like that. So those are a couple of really wild examples, if you will. You know, I can confidently say that this generation about which I was talking, the space generation or the Mars generation, as President Obama calls it, it's seriously engaged with exploration, including the students, all of you here at Bar-Ilan. They want to make your mark, create your milestones, and go new places. Every generation wants to do that, but in this case, we're expanding humanity's reach throughout the solar system, a truly amazing and huge undertaking. Question right there.
You talked about the race to the moon was fueled by conflict. It was a race between two beings. And the race to Mars, you said, should be a form of cooperation. How do you see this cooperation made between so many different nations and people come together?
The greatest example I can give you is the International Space Station. It is an example of how collaboration and cooperation are being employed to make what we do off Earth make life better on Earth. The challenge is no longer competition between and among nations. The challenge today is the survival of humanity against the elements. Whether we're talking about climate or whether we're talking about disease or whatever it is. So the things that we do on the International Space Station today are multiple nations of the world coming together to battle with challenges to humanity's very existence. We're trying to, at NASA we have a vision that says we reach for new heights to reveal the unknown, so the things that we learn and know make life better for all humanity. So that's what we try to do when we work with the Israel Space Agency or the Russian Space Agency or the South African Space Agency. We're all looking for common goals and missions that can pull us together. The reason we coexist on the International Space Station, we have done that for 16 years in spite of, you look at the relationship between the United States and Russia, not really good down here right now. But on the International Space Station, if you talk to any cosmonaut and astronaut, they are really fired up about the work they're doing and the partnership that they have. In fact, Scott Kelly's picture is here. He just finished a one-year mission. Scott didn't do it alone. His partner was Mikhail Kononenko, a Russian cosmonaut, and they did it as a team. And they always talked about the importance of the team. So the things that we do today, we're battling against threats to humanity, not country against country. And I think that's critically important. I'm proud that no matter where you live in the world, no matter where, you've probably heard of at least a little bit about what NASA has been up to recently. Whether it's discoveries that he mentioned over there from Curiosity on Mars and the Mars Reconnaissance Orbiter that discovered the ice flows, or whether you're talking about us reaching Pluto with a New Horizons spacecraft that just discovered this quote-unquote dwarf planet that people thought was just a dead icy rock and found out it's a really booming live planet with an atmosphere of some sort, with ice, with all other kinds of stuff. To the one-year mission that was just completed by Scott Kelly and Mikhail Kornienko on the International Space Station. In spite of everything going on down here between their two countries down here on Earth. That's really, really, really important. You know, our journey to Mars is a huge undertaking. Huge undertaking. And as I said, it's one that must be done in partnership with many nations. That journey is being furthered with the International Space Station for more than 15 years, as we talked about before, in partnership with many other nations. We're learning to live and work in space for the long term, making breakthroughs in human health and demonstrating technologies for traveling farther. Next, we'll use the Orion spacecraft and the Space Launch System, our heavy lift rocket, to reach the proving ground of deep space that I mentioned earlier, that the area in the vicinity of the moon, between Lagrange points 1 million miles from Earth, all the way down to geosynchronous orbit of Earth and everything in between. So that's where we're going to be in the decade of the 20s. And we're looking for breakthroughs in human health, and we're demonstrating technologies that allow us to fly farther. Yeah?
I recently saw that SpaceX, a private company,
Yeah.
has helped NASA deliver an experiment to the International Space Station. Is a private company involving NASA, the future of space?
Let me even make what you just said even better. Hopefully everybody heard that SpaceX was helping NASA deliver. SpaceX isn't helping us. SpaceX delivers cargo to the. We don't deliver stuff to space anymore. NASA is not in the transportation business. In the days of the space shuttle, everybody relied on us to carry almost everything to low Earth orbit. The International Space Station was constructed mainly because we had the shuttle and a giant cargo bay, and we could take all the components up there and over more than a 10-year period of time, construct the International Space Station. We made a conscious decision after we lost the shuttle Columbia, which is very painful to many of you here, but when we lost the shuttle Columbia, the conscious decision was made that we were going to phase out over the next 10 years or so use and reliance on the space shuttle, because we wanted to go explore. We wanted to go to deep space, and we couldn't do that and maintain a low Earth orbiting access vehicle like the space shuttle. So we said, we're going to phase out of the space shuttle, but simultaneously, we're going to work with American industry and entrepreneurs to develop an alternative transportation system to carry cargo and crew. Today, and it's been almost 3 years now, SpaceX and Orbital Sciences have taken over the responsibility for delivering cargo to the International Space Station, and not just low Earth orbit. SpaceX has delivered cargo satellites to low Earth orbit, to geosynchronous orbit, you name it. And that's critically important for us, to have them be able to do that. Next year, you're going to see 2 vehicles fly. That will be the first time that commercial entities will have built vehicles intended to carry humans to space. Next year, 2017. So that'll be SpaceX and Boeing. The next year, we're going to fly the very first crewed mission on those 2 spacecraft, on Crew Dragon and the Boeing Starliner. And then the delivery of crews to orbit will no longer be totally dependent on the Russians the way we are today, having to rely on Soyuz. We'll be able to get our crews to orbit the way that we want. And then after that, we're going to use Orion, the Orion spacecraft, and the Space Launch System, or SLS rocket, to reach the proving ground of deep space and shake out some of the cutting-edge new technologies, such as solar electric propulsion. We'll need to travel even farther. By the 2030s, we'll move out into another region that we call the Earth-independent phase, where we'll finally take our missions out to the Martian region. Even then, we are going to utilize commercial, entrepreneurial, academic means to get cargo, whether it's to get it to lunar orbit, where we can jump off, or maybe even, as some of you know, we signed an agreement recently to assist SpaceX, with trying to get a vehicle, trying to get a Dragon to Mars. That would be incredible. It doesn't make any. Remember, my response back to the question there, this is not competition, not for NASA. It is cooperation to advance humanity's quest to solve a lot of the problems we have. And I said before, we need every nation pulling some share of that load. We need every entrepreneur, we need every corporation that does anything about space. We really need them. In that Earth-independent phase, everything we need we'll either have to take to space, we'll have to make it on the way with 3D printers, or we'll have to produce it when we get there. Oxygen, made from carbon dioxide in the Martian atmosphere. Oxygen and hydrogen, made from ice that we take out of the Martian soil, melt it, hydrolyze it, and turn it into its constituents of hydrogen and oxygen. So we're going to make the fuel for our Mars ascent vehicle from stuff that's already there on the planet. The journey to Mars is the biggest thing humanity has ever undertaken. And it's thrilling to think that somebody in my granddaughters, I have 3 granddaughters, 9, 13, and 16. Somebody in their generation, or somebody in this audience is probably going to be among those to take the first step on Mars. But again, it must be a global undertaking. Question back there in the back, all the way in the back.
Hey, I have a question about rather when we land on Mars. Is there any theoretical plan for terraforming Mars?
No. Does everybody know what terraforming is? And I won't. Let me not answer it. That's a blunt. NASA is not currently working on terraforming Mars. Terraforming is injecting heat into. What do I do, man? Let me do this. Let me see if. No, I'll let you play with it.
Tell me the right answer.
Who speaks Hebrew? Right with me. Which one? Which one? Escape. Ah! Thank you. All right. Terraforming means putting heat into the surface of Mars and having it heat up and melt a particular section of it, and then over time that heat spreads out, and eventually Mars goes back to being the way Mars was millions and millions and millions of years ago. Not in my lifetime. So NASA is not actively working on that. We've had experiments that we've participated in the Antarctic, where we've experimented with terraforming, and down there it has worked on a very, very, very limited scale, so we don't see it as a solution to life on Mars.
Are there any dangers associated with opening a channel between us and Mars?
Yes. Are there dangers?
Dangers?
Yeah.
You know, like opening a Pandora box, we don't know about it.
You never know. But I don't think there's danger of opening a Pandora's box. The danger is the risk that we know about. 2 big ones for us. The ultimate risk is what we call intradecent landing. How do we land large payloads? We're talking about, Curiosity weighed 2,000 pounds, a ton. When we send humans to Mars, we're talking about landing 20 or 30 metric tons on the surface of Mars. We don't know how to do that yet without having it just plunk down and break into thousands of pieces. So entry-descent landing is a big challenge for us. I mentioned SpaceX and taking Dragon to the surface of Mars. They use something, if you've seen them, in returning the Dragon, the first stage, the Falcon 9, to a barge and to a landing site on land. What we're learning from them is what is the relative success, or what is the relative value of supersonic retropropulsion. So we don't do that. We didn't do it with a shuttle because the shuttle was a glider. And so we flew it back into the atmosphere, slowed it down, and then landed it like a glider. But if you're sending a rocket that doesn't have wheels and it's not going to land like that, how do you safely land it on the surface of another planet? And so SpaceX is looking at supersonic retropropulsion, as is Blue Origin. And people don't talk very much about Blue Origin. Blue Origin and their New Shepard has launched and landed the same vehicle 3 times now. So they have had 2 successful returns to Earth from suborbital flight, granted. So there is a, when you see Jeff Bezos and Elon Musk arguing back and forth, tweeting back and forth in competition, that's because they're doing 2 different things. One's doing suborbital, the other's doing orbital, but they're both bringing things back to Earth and landing them vertically, which has been done before, but nobody's thought of doing it commercially. And so that's the value in that, and that's what we will gain if they're successful in landing something on Mars. This is one of my favorites because, so how many of you saw The Martian, the movie? The rest of you need to go see it. Okay? You gotta go see it. It is awesome. And the reason it's awesome is because it is so real. You know, we're not growing potatoes yet on the International Space Station, but there is an experiment, and this is not a NASA experiment. This is a commercial experiment called Veggie. And we're growing vegetables on the International Space Station. This is the crew down here eating for the first time several months ago lettuce grown on, lights down. Okay, can we turn the lights down again a little bit dimmer up here if you can control the front? Can we do? Yeah, that's good. Okay, but Veggie actually gave us the ability to grow leafy lettuce. We're now growing cherry tomatoes. We're looking at growing grapes. I mean, you name it. Because remember, I told you when we go to Mars, we've got to take it with us. That's heavy. We really don't. That's the last alternative, is to take it with you. Produce it on the way. Grow vegetables, or make it when you get there. So that's what we're working on. As a first step to the journey to Mars, the station, the International Space Station, is a vibrant and robust laboratory. On the International Space Station, we perform research with economic and societal benefits not possible here on the ground. Station enables us to work off Earth for Earth. Every single partner nation has made unique and invaluable contributions to the space station and to the research that we do there. Our international crews are critical in carrying out research from across the world. In any given 6-month period of time, we work around 250 experiments aboard the International Space Station. And some 90 different nations have taken advantage of that, advancing research from academia, industry, and other government agencies and people of many backgrounds. And that's one of the things that we are here talking with the Israel Space Agency about, is making them a part of that research that's going on the International Space Station. And that's going to be critical. So as you all go through your undergraduate and graduate studies here, think about the laboratory of the International Space Station in addition to the laboratories here on campus. One of the station's greatest legacies is its powerful example of ongoing positive international collaboration among the, I can see them. So who keeps turning the lights on? I got a few more slides. Anyway, all right. But one of the station's greatest legacies is its powerful example of ongoing positive international collaboration among the ISS partners. Next. Our astronauts and cosmonauts also serve as subjects themselves. So we're guinea pigs. We are actually the test subjects on a lot of the human experiments that go on. That work was highlighted in the recent mission the United States and Russia undertook together to put 2 of our crew members in space for 1 year, Scott Kelly and Mikhail Kononenko. Another experiment that went on simultaneously was because Scott Kelly has an identical twin brother, Mark Kelly, who was an astronaut. We took one brother on Earth, one brother in space, and we did for the first time a human genomic study called the twin study, where we're trying to see if there's a difference between DNA development, are there changes in Scott that didn't occur in Mark based on the different environments in which they existed. Question right there.
If life will be found on Mars or a different planet, how do you estimate the biology of their organism will be similar to ours or completely different? DNA,
Yeah.
How do you estimate it?
We don't know the answer to that, and that is, her question was, if we get, when we get, I'm going to change your question, you said if. When we put humans on Mars, are we going to see changes in DNA? Is life going to get different? You know, are we going to physically change or emotionally change? We don't know, and that's why we experiment. That's why it's called exploration, and I'm not being cute. We are involved in exploration. We're trying to, the twin study, 1 whole year looking at identical twins, one in space, granted low Earth orbit, but still exposed to a different level of radiation than the one down here on Earth. If we see significant changes in DNA, a couple of conclusions we might be able to make. If we have to go back and do some more work to determine whether it was radiation that did it. Maybe it was lack of gravity that had effect on the DNA changes in Scott, if that happens, and I don't know yet. We see that there are changes in the human immune system when a crew member gets on orbit. Initially, the human immune system kind of starts to go downhill. It just stops functioning for a while. over the course of a 6-month flight, it goes down, reaches some low, and then it starts to come back up again. And in some crew members, they get hypersensitive. The human immune system really picks up, and a speck of dust landing on their arm causes them to get a rash. Those are the kinds of things we don't yet understand.
Yeah, it will find a different life.
Yes.
Would be similar to ours or a different one, not our DNA.
Yeah. I don't know. No, her question is the question. Remember I said the 2 things we are looking for. How did we all get here? And are we alone? I didn't say, are there other humans? That's not the question. The question, is there other life? And even here on Earth, the life forms, the identity and characterization of them are infinite. Fish, animals with 4 feet. We've got different creatures here on this planet. We just don't think about it that way. We may find that there are certain species on Mars that don't exist on Earth. We may. Who knows? I don't know. Question, nope, you already asked one. I can't do you twice. Yes.
You laid out all NASA's plan for following decades.
Yes.
Is there a plan for building a permanent settlement of the moon?
I'll tell you who talks about it. NASA does not have a plan for a permanent settlement on the moon. NASA does not have a plan for a permanent settlement on Mars. NASA's job our responsibility is to be the cutting edge of technology and innovation so that people can follow. Remember I told you we got to the point where we felt very confident that we didn't have to carry things to space anymore. We didn't have to transport things to low Earth orbit because we felt we had collaborated with American industry long enough. They built our spacecraft. We felt very confident that they could take care of delivering things to space for us. We feel very confident that over time, commercial enterprises are going to take over low Earth orbit. They will provide the low Earth orbit infrastructure where people go, stop, plan, press on to lunar orbit or to the lunar surface or to Mars. We think the same thing will happen on the surface of the moon. Google, for example, has a prize going on right now, Google Lunar X Prize. You're winning? I didn't know you were winning. I thought you had a team that was a finalist. That means you're winning? Are you just being confident? Or do you have points? I'm serious. I just kind of follow it up. I see one person going, no. But you're confident. That's what you need. Yeah. We were just talking about that in the car. I think there are, 3 or 4 contracts that so far teams have proven themselves well enough to do that. That's important. And so is NASA going to establish a permanent presence on the moon? Why would I do that? Why would NASA do that when what's your name? Emir? What's your last name? President Emir Melnikov of Space Ventures Israel is going to put a colony on the surface of the moon. So why would NASA go try to do that? You are dreaming of doing exactly what this is all about. It's opening the frontier so that people can come in, normal people can come in and do what only governments can do initially, which is take the risk of doing really dangerous but exciting things until it's proven to be safe or at least worth the risk. We think everything we do is worth the risk, but we also are serious enough to know that we can't expect a private company or somebody else to go do some of the crazy stuff we do until we've demonstrated that it's not really crazy. Like going to the International Space Station. That's kind of considered to be common today, but it took some time. You're going to be the president of a company that's probably going to establish the first. I'm serious. Yeah. Okay. So that's why we're not trying to do that. We're trying to make room for you. Question right next to you. Today, there is only the ISS that's the platform for doing research in space, and that's the problem. The problem is the ISS, like everything, is a machine, is a man-made structure, and it has a finite lifetime. And so one of the things that we're really pushing now is for industry, academia, entrepreneurs to look for an alternative platform, whether it's small modules or platforms of any kind where other research can be done. The Chinese, for example, have Tiangong. That's an example of an alternative platform where research can be done. We're trying to talk our other partners into, everything doesn't have to be in the orbit of the International Space Station. We could have platforms in equatorial orbit. So that's what we're trying to do, is get other people to make platforms where research can be done. Back there. And then because we got about 8 minutes. Yeah, hold on. I hear somebody asking about The Martian. Go ahead and ask your question, and then I'm going to the young man with the mic. Don't. You can yell it after she asks her question. Go ahead. Very, very, very. The question was, how accurate is The Martian? That was the point. It is incredibly accurate. There are some pieces of it that have been overcome by events. Some of the technology that was used in The Martian, we don't do anymore because we've passed that technologically. Other things we don't have yet. We don't have a Mars ascent vehicle, for example. When Luke Watney got in the rover, by the way, is an old rover. It's like one of the rovers that we've been driving around the desert probably 10 years now out of the Johnson Space Center. We're looking at more robust rovers, more maneuverable rovers and the like. So very, 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 one of the things that both the author of the book and the director, producer of the movie wanted to do was make sure that it was as true to science as possible. So, there is always some literary license taken. For example, there is no big dust storm like that on Mars. But it's really important to get the movie started, okay? So without the big dust storm, then you don't have the thrilling movie that you had. So that's important. But for the most part, true to life. Question up there, and you may have to yell it. Yes? You're gonna interpret.
He says that Hillary Clinton mentioned that if she's elected, she's going to shine a light on what happened in Area 51 on Bar-Ilan.
Yes. I'm going to ask Hillary if she's elected. I have no idea. I think it's great, to be quite honest, but I don't know. Now, however, because you probably can't see them, I just wanted to show you where we're going. Remember I talked about commercial vehicles carrying crews to space. These are two examples. On your left is the Boeing CST-100 Starliner, and on the right is the Crew Dragon. These are the two vehicles that are going to fly next year, and beginning in 2018, we're going to have American astronauts and our partner astronauts flying to the International Space Station and other low Earth orbit destinations on those two vehicles. Excellent. As exciting as things are, this is all hardware today. We're not talking about some picture on a piece of paper. The Space Launch System, granted, that's an artist's concept of what it looks like. It's the largest heavy lift vehicle that will have been created to date. The metal for this, the barrel sections, are being cut and welded today in a facility called Michoud outside of New Orleans, Louisiana. Up on the top is the Orion crew module. Orion has already flown once. It flew in December of 2014 on an uncrewed mission. It went farther than any spacecraft intended to carry humans to deep space had gone in more than 40 years. So Orion has flown incredibly successfully. On the right is an engine test down at Stennis on the Mississippi coast. That's an engine test of one of the engines, one of the 4 engines formerly used in the space shuttle that's going to be used to launch the SLS into space. Next one, if you would. In addition to human exploration, and we haven't talked a lot about robotic exploration, but on the 4th of July, for us in the United States, Independence Day, we're going to have a big event when Juno, which is a satellite that is going to be drawn into Jupiter orbit, into a polar orbit of Jupiter. That happens on July 4th. It's been a 5-year mission. We launched it back in 2011, I think, and get there and enter Jupiter orbit. What's unique about Juno is it's the first spacecraft ever made by anyone to go to an outer planet, to go to deep space without nuclear power. It's got massive solar arrays with the types of solar array technology that you develop here in Israel that has allowed it to use the sun's energy, photons from the sun, to fly all the way to Jupiter. And just the other day, it went over the boundary where it is now under the influence of Jupiter's gravity. So it started out in the influence of Earth's gravity, then it went into the influence of the sun's gravity, and a few days ago, it is now being pulled toward Jupiter, where it's going to enter orbit on the 4th of July. Next one. This is OSIRIS-REx. Later this year, we're going to launch this satellite. OSIRIS-REx is going to do something that only the Japanese have done today. It's going to fly to, going to intercept an asteroid called Bennu, B-E-N-N-U, and it's going to land on Bennu, collect some samples, take off, and then come back, and it'll return to Earth in the period of about 2023, bringing samples from Bennu. Next. The James Webb Space Telescope, and I know it's hard to kind of make this out. This is a clean room floor, but if you look at all that shiny stuff on the bottom, that is today's telescope. Those are the 18 segments that make up the James Webb Space Telescope, the most powerful telescope known to man to date. When it is finished, and we launch it in 2018, it's going to go 1 million miles from Earth, and it's going to be able to look to the farthest reaches of our universe as we know it today. It's going to dwarf what we learned with the Hubble Space Telescope, because it's an infrared telescope that if it's going to be out and its temperature is going to be almost absolute zero. So anything that's moving, anything that has any heat from it, is probably going to be detected by James Webb. And we're going to look in some of these thousands of planets that we're discovering around other suns today, and we're going to look into their atmosphere and determine whether it's hydrogen, nitrogen, carbon, oxygen. We're going to be able to tell you what the makeup of the atmosphere of some of these exoplanets is. And that's coming together for a launch in 2018. What's unique about James Webb is that it is a segmented telescope, so we've got to take this whole shooting match here, fold it all up, and put it in the nose cap of a launch vehicle. And then when it gets to space, it's got to unfold very meticulously over its 1 million mile journey, 1.5 million kilometers to get to a Lagrange point where it's going to begin to operate. Next one. I want to show you this real quickly, because remember we talked about diversity and inclusion earlier? I just want you to, this is Sunny Williams. Some of you may know Sunny. She is one of the 4 crew members that's in our commercial crew cadre. In other words, she is one of the 4 test pilots who's been selected to fly on the first commercial spacecraft that we've
Congratulations to all the women at NASA working as engineers, aviators, research scientists, and astronauts who are broadening the possibilities of space travel and making a future possible for humanity in a galaxy far, far away.
Thank you for inspiring and empowering today's generation of young women and girls to seek careers in the fields of science and technology, and for your invaluable contributions to space exploration. The heroic women of NASA continually inspire girls to enter the space program, so I'm so thankful for engineers like Charlie Blackwell-Thompson, who will be the first woman to oversee a NASA liftoff and launch team.
Being the launch director for this inaugural launch is pretty exciting. We're going to have a vehicle that is over 300 feet tall. At liftoff, over 8 million pounds of thrust. I can't wait to see that. It's going to be amazing. When you couple that with the state-of-the-art spacecraft, Orion, the destinations and the capabilities that these two bring our agency is something amazing. Being in charge of the launch team on EM1 launch day is something that I very much look forward to. I look forward to seeing our team in action. I look forward to looking out the window and gazing at that vehicle as it stands ready to launch.
Learn more about Charlie and heroic women like her at nasa.gov.
make the future that we've been talking about become a reality, we need to welcome and make use of the diversity of our modern world, especially people of color and women. Those groups have been far too underrepresented in science, technology, engineering, and math, or the STEM fields. We're being proactive to change that because it's a huge pool of talent and it will help with the expected shortfall of STEM workers in the coming decades. It is never more true than here in Israel. You have an incredible shortage of women in the workforce, in the technical workforce. And so we're hoping that you're saying, why not? Why? Huh? Okay. You're there, but I mean, you know, you're a one. Okay, good. Women are going to be making a lot of the future milestones and exploration for us. So that's why I wanted to show you that. So, you know, as I said earlier, our legacy must be inspiration for today's students. They are the next Martians, when you get right down to it. I've been to every continent except for Antarctica during my tenure as the NASA administrator, and everywhere, every single place I go, the space generation is making itself heard. These young people, you all, are passionate about learning and making humanity capable of greater things. You've shown that in your questions today. You know, every single question you asked was about the future. I don't think anybody here, not a student, asked me a question about the past. And that's what's so important. Unlike some of us who like to dream about the past and reminisce and pat ourselves on the back and talk about what we've done, you're worrying and wondering about your future, and that's absolutely critical. As someone who has had the privilege of floating above our planet and seeing this very piece of land where we are now, where we're sitting right now, in its own context, in its geography, and where it fits into the entire planet, I can tell you that space is going to change humanity's perspectives and life on Earth in countless ways. It already has. Just think of the impact of Bar-Ilan Ramon. It already has. And it will continue to do so as long as we let it. No one said our journey would be easy. You definitely have not heard me say that. It is going to be incredibly hard. But I found it to be 100% worth it. Every single risk we take, every single thing we do, every single second that Bar-Ilan spent on orbit was worth it. Trust me, it was worth it. Every day, I interact with people around the world who are smart, visionary, passionate, and dedicated to giving humanity new capabilities and improving life on Earth. It doesn't get any better than that. For me, it does not get any better than that. Coming here and being among you and hearing your questions about the future, it doesn't get any better than that. What's your name? I didn't see you down there. How old are you? 11. Wow. Thanks for coming. Did you bring your dad? Thanks for bringing your dad. Are you listening to music while I'm talking? You are? Am I dull? No? Okay, that's all right. Exploration is an aid. The truth sometimes hurts, but she's 11. She's the real Mars generation. Exploration is an international undertaking because many nations of the world have selected their best, most innovative, most skilled individuals to train for the ultimate journey, away from the confines of gravity into the heavens, where our planet can be viewed as a global community, as an integrated entity, not a collection of single localities. They're sending their very best scientists and engineers to help develop new spacecraft and participate in international missions to help us reach new destinations with humans and explore places where humanity cannot yet go. So, finally, working together, we can increase knowledge about our planet, our solar system, and our universe, and we can inspire the next generation to make their own leaps, not only in discovery, but also in global collaboration. We're inviting all people of the world to join us in our ongoing quest to turn science fiction into science fact and make the impossible possible. We're excited to count on the Israel Space Agency among our partners, and to be working together with them in this challenging and exciting quest. And I personally, look forward to the discoveries to come as we bring all of you into the family of explorers. So thank you all very much. You have been so